Okay, thanks, Eric. For this, we're going to do Q&A as part of mine?
Yes.
Perfect. All right. And actually, what I would like to do is make it more of a discussion rather than a presentation, so I'm willing to take questions during the middle of my talk. So just raise your hand or throw something that won't leave a bruise, and I'll take your question. Okay. So I'm going to share with you some ideas of Comcast perspective on SDN. And as I was listening to some of the talks this morning, one of the things I realized is that the perspective that I'm going to share with you today is really being driven by the fact that Comcast is a service provider as opposed to a data center, right? Clearly we have data centers, but we have a very, very large network, and we have a need for driving features onto this network infrastructure in order to support our application friends. The size of Comcast is like over 1,000 locations where we have significant routing infrastructure. Okay, we got a lot of different locations and a lot of hardware out there, and we need new features, and we need new features very, very quickly. So my perspective here is, how do we accelerate? The application guys are beating the network guys over the head, right? We are beating the vendor guys over the head to deliver new features for us. And so, is there a new way to think about how we set up that ecosystem? And maybe this is a new way to think of what SDN is. So let's see if I can get this part. Nope. All right, here we go. Again, so from our perspective, I'm thinking about how we can accelerate features into our network infrastructure. And so from my perspective, I'm really thinking about the routing ecosystem as opposed to the data center. Okay, and I would imagine if you were to ask people what SDN is in this context, they would say it's something like, well, you've got a controller sitting there in the middle. You've got OpenFlow, which is programming state into the routing infrastructure, and then you have applications sitting above the controller that talk to the controller via REST. And if that's the ecosystem, or if that's kind of the paradigm for SDN, we have some questions about whether that's really going to work for us. And so the reason we have questions, okay, here we go, is when you think about if you look at that bottom thing below the controller and the router itself, if you look at what really happens inside of that router, we have these open protocols like BGP and ISIS and PIM, but basically everything else is locked down. I've got a proprietary CLI in there, a proprietary OS, proprietary chassis, and probably proprietary ASICs. Okay, and now I've got OpenFlow in there where I have to, if I wanted to try to leverage OpenFlow to kind of program state into the router, it's not something that I can really control. I have to get the vendor to build me an instance of OpenFlow to run on there. I have to potentially get my controllers to support OpenFlow as well. And so this is a pretty locked down ecosystem. And does this really provide us the agility we need? Right? We question whether it does. I really do have a PhD, even though I can't figure out how this works. Right? Thank you. You got to press the right button, literally the right one. Okay, so think about this. Think about this. The application guys want agility. They want to get things out there really, really quickly. Right? They beat the network guys on the head to say, hey, we need these new features, and so we're dealing with the routing space. Right? Again, Comcast is very, very big. We're not a single router company. We have many different vendors in our ecosystem. So when you think about if we need a new feature and that new feature touches multiple vendors and maybe touches OpenFlow, look at all the different things that have to be involved, right, for me to get that feature out there. I've got to talk to the router vendors, and I don't know how many of you talk to router vendors for features and whatnot, but the basic answer is 6 months, 9 months, 12 months, or something like that. If you need it from multiple vendors, and then you need to coordinate across them, and they have to go to IETF and do things in that space, so it takes a long time to get new features in the networking ecosystem. OpenFlow even adds another complexity on top of that. Right? Does it really provide the agility we need? Well, maybe if you want to just kind of program TCAM state, that does it for you. But what if you need something in addition to that? What if you need something more than just fiddling with forwarding state in the router? When you think about why OpenFlow exists, the Stanford guys, what they wanted to do was basically come up with new concepts of control protocols and run it directly on their existing campus systems. They didn't want to test it on a couple of Unix boxes, right? They wanted to run it at scale, and they couldn't do that. So they came up with this idea of, well, if we're able to somehow program state into this ecosystem, since we can't run our code directly on the router ecosystem, what if we were able to kind of push some API information down to the router that would tweak the set of forwarding entries, right? And so that's kind of how OpenFlow came about. It came about because the Stanford guys wanted to test out new ideas with the control protocol, but they couldn't actually put their code on the box itself. So they basically abstracted it, have an API, and they run their code on a control plane separate from the routing infrastructure. And then they send OpenFlow messages down to tweak what the TCAM forwarding state is. Right? So that's kind of the existence of OpenFlow. their basic premise here was that you can't run your own code on the existing router legacy infrastructure. Oops. It turns out that's no longer the case. There is at least one router vendor, and I'm not talking white boxes, I'm talking a router vendor platform, where they open up their box. What you can actually do is basically run your own code, compile your own code, and drop it directly onto the box. So your code is going to run in parallel to what existing control plane is running on that vendor box. And so when you think about it, what we're suggesting here is that given we have this open infrastructure on at least one router vendor platform, what we can do is we can if we have a new feature that we need, Comcast, can write the code. And we're no longer, prevented by getting a new feature by getting onto the vendor timeframe, so the development timeframe. So we can control when we need new features, right? We can make the platform agile. And what we're doing is we're calling this the hybrid open architecture. I'm not pitching a particular vendor, but we are pitching kind of this approach, right, for how a router should in fact work. So to test out this concept, what did we do? Comcast is interested in this concept of segment routing. I'm not sure if people are familiar with what segment routing is, but it's kind of one of these ideas. We've talked about complexity, managing complexity in the network. What segment routing allows you to do is to have the application basically pick the path the packets take through the network. Okay? So instead of having the network have all these business rules as to, oh, this particular application should go through X, Y, and Z, you basically put that information into every IP packet, every IPv6 packet, it's specific for v6, that allows the application to steer its traffic through the network. The other thing you can do with segment routing, besides steering traffic through the network, is the endpoints, the information you're putting in that header, may actually be an application endpoint. So when you combine the two concepts together, this effectively satisfies service chaining, right, which is one of those things that are often kind of folded under what you need in the SDN space. So Comcast is interested in this technology, and so we tested this out. We actually wrote our own instance of segment routing, did it with Go. Go, you can actually run interpreter, you can compile it. We compiled it, and we ran it directly on this vendor's platform, in addition to all the other configuration that was running on the box, the classic vendor configuration. We had to make a couple of changes to the command, the COP stuff, which is the filter to prevent or to what goes up to the control plane. So we had to make a couple adjustments there. But basically what we did was we dropped this binary onto the box, and it worked. We were able to add a new feature to the router without having the vendor involved at all, right? That sounds pretty powerful. So if you have an idea of something that you want to do, you don't have to try to convince the vendor of the value of it. You can actually mock it up yourself and test it out, right? So that was kind of the aspect of what we're doing here, is to test out this sort of concept. What we did is, we built the code, and then at IETF in Toronto, we actually demonstrated our code running on this vendor platform interoperating with Cisco's version of segment routing and with an instance from a university in Europe, UCL. So, here we are, we're an operator, we're not a router vendor, but nonetheless, we can start adding our own features to these boxes based on our own needs. Very, very powerful. One of the other things that we actually needed to do as part of segment routing was we wanted to change kind of how ISIS worked. We wanted to have administrative tags. And it turns out this vendor's implementation of ISIS didn't support administrative tags. So what did we do? We took Quagga, we hacked the feature into Quagga, we dropped Quagga onto their box in addition to our segment routing code, and then we turned off the vendor's version of ISIS. Right? So we needed a new feature in our IGP. We're able to kind of build that ourselves and then basically turn off the vendor's version of the code. So what are we kind of pitching here? What we're doing is we're pitching an architecture where today we are all the way on the left. And you can kind of think of, 99% of the code running on the box is vendor code, and we've got 1% of our code running on the box. But over time, as Comcast needs new features or other operators need new features, they can build them themselves. Maybe they can, in fact, open source these ideas, right? And so I can go to the internet community to get some new feature that I need and basically run it on the box. So the thinking is that over time, instead of it being 100% vendor code running on these boxes, over time it becomes part vendor, part open source. It may not actually end up all the way on the right-hand side being a white box. Maybe I will always need or want some vendor sort of code running there. But the ability for us to add our own code or to take stuff off the internet, That's very powerful. It allows us to be agile and do things that we need to do on our time frames. Okay. So what does this really, really mean? We think that this hybrid open architecture enables agility. Again, if we have a specific feature that we want to run on our network to empower our applications, we have the ability to add that feature ourselves. We're no longer encumbered by the vendor development timeframe. We think this is what SDN is. Okay? And again, I'm not sure what everyone thinks of SDN. Many people think of SDN as being kind of the controller layer and kind of, you just have, the OpenFlow stuff talking to the router infrastructure. We want to run the code directly on the routing infrastructure, our code. We're not going to completely rewrite the router code, but if we have new features, we want to have the ability to drop that code onto the box ourselves. And think about this. Again, if comparing it to a white box, I don't need to stand everything up. I can basically leverage the vendor's code for the stuff that works for me and just add the things that I need, right? I don't have to build everything from the ground up. So I can have the best of both worlds. I can run the vendor code on the features that they do really, really well, and I don't want to mess with. I don't ever imagine that I'm going to write a version of BGP, right? So I'll just use their version of BGP. But if I needed new features in ISIS, or I wanted to do segment routing, or I wanted a new way to export information off the box, I can do that. Okay? Now think about this. IETF, rough consensus and working code. The IETF is kind of cool because anyone can kind of show up and do it, and kind of have an input. But when you think about it, the rubber hits the road with those engineers that are sitting in Sunnyvale and San Jose. Those are the guys or girls that are going to be actually writing the code, right? So they tend to basically be able to kind of control what happens in the IETF. If, on the other hand, any one of us have a feature that we need and want, we can build it ourselves and put it on the code. So it opens up this IETF environment to not just be vendor dominated, but basically anyone that can write code can participate. Okay? And so I think it may in fact change how IETF works. And honestly, I think that might be good. Taking a lot of this application sort of concept and applying it into the networking space, I think that's going to be very, very beneficial. Okay, quote time. With great power comes great responsibility, all right? So here we are. We've got our network infrastructure, and we're going to be dropping our own code onto this platform, right? We're going to stumble. We're going to scrape our knees at times. We have to be aware of that. But the risk there of that happening, we are considering that risk as having a tremendous amount of reward, right? Because we basically get to drive what's important to us and run it on our network infrastructure. So certainly, we've got to be careful. But there's a lot of value that gets out of going down this path. Okay. And so that's it. So if you want more details, I presented basically this concept at NANOG in June. So there's more detailed presentation there. I've put my email address up here because again I have to leave here in a few minutes. So if you have questions, comments, thoughts, you're crazy, whatever, all are welcome. And thank you. Question. So the code that we have running now is just kind of like in our test environment, right? It's still kind of being worked into it. Certainly we have to get those guys comfortable with this, right? Okay. So part of the hope here is to drive or to share with this community the value in terms of doing this, that we can hopefully collectively get our router vendors to embrace this model, right? So we have one that for sure, and maybe others will kind of jump on doing the same sort of thing. Okay.
So would it be operational without all the vendors embracing the model? I mean, would you be deploying this with only one vendor in your network? Would you go live with one vendor?
We would have to. Right? I mean, just getting it up, we would have to. But again, the goal would be to get this across all the platforms. Yep.
Thank you.
Have you discussed support with your current router vendor? What have they said about how they would support you with this?
With this paradigm, it's basically you're on your own. Okay. But the other thing that I want to mention here is that we're talking about networky sorts of things, but it's just software. Maybe I might want to put other stuff in there. Comcast is a really, really big video company. Maybe I'd want to put a cache on there, right? And I'm going to take your question in a sec. Anyone here heard of Van Jacobson? All right, okay. So in the last couple of years, Van Jacobson has been, pitching, this name data networking kind of concept. And kind of fundamentally what he's doing or suggesting is that, there's so much content on the internet that is cacheable. We should make the infrastructure, we should make caching a first-class citizen of the network. I think directionally he's right. I think what I'm proposing here is making software a first-class citizen of the network. And caching is just one of the services you can build on that software, right? Okay. Okay. I think we're good. Oh, we got time for this?
Yeah, take another question.
Okay, go ahead.
So what's your exact expectation with regards to delivering your software? Is proper API like ITRS to modify your RIP or ISS, or you just want to run SSD binary in combination with binaries provided by a vendor?
I'm not quite sure I understood the question. Could you state again?
Do you want to code your own ISS binary, compile it, and run on my kind of infrastructure, or have proper interface into RIP and maybe into IGPs?
So we haven't gotten there, right? In terms of how much sort of interaction we need between the different routing protocols and whatnot. But again, I think it's this paradigm of opening it. We're going to get many, many, many more people involved, right? I think Russ had mentioned about innovation that isn't going to happen in the white box space. It only happens if people are going to get paid. Well, instead of paying people for vendor C and vendor J and vendor whatever, there's going to be value to people within Comcast or Google, whatever, that are going to want to write features into this routing infrastructure, right? So I think, it's just kind of like sharing this vision and then trying to get people to, buy into it, and then that will help drive, what sort of features we really need by these software components and whatnot.
If you could better formulate where you want to get them into, it would be easier for vendors to provide the way to get into it.
Right.
CMTS or both?
Yes.
When you mean router?
Yes.
Both?
Everything.
Okay.
Everything. Yeah, okay, we're done. Good? Again, email. Thank you.